Welcome to Code Beyond Code, where we explore the cutting edge of software development. I'm Maya, a tech strategy consultant who helps teams adopt transformative development practices. And today, I'm absolutely thrilled to be joined by Kai, a genuine innovator who's been making waves with something called vibe coding. Kai, I've been following your work since you won that massive Bolt.new hackathon, and I'm fascinated by how you're reframing the relationship between developers and AI. For our listeners who might be hearing this term for the first time, what exactly is vibe coding, and how did you come to develop this methodology?
Thanks so much for having me, Maya. Man, I'm excited to dig into this. So vibe coding is essentially a methodology that completely transforms how we think about coding with AI assistance. The breakthrough moment was during that hackathon you mentioned. We were under this intense time pressure, and I realized we needed to stop treating AI as just a fancy autocomplete tool and start approaching it as a creative partner. Vibe coding recognizes that coding is fundamentally a human activity, right? It's influenced by our psychology, our environment, even our emotional state, what I call our vibe. In this approach, we become conductors who direct AI to transform our creative vision into functional code. And it's not just theoretical. We've shipped multiple production apps using these techniques, cutting development time by more than half while actually making the process more enjoyable. The magic happens when you align AI with your creative vision, rather than trying to micromanage every line of code it produces.
So Kai, I've been hearing this term vibe coding all over tech circles lately, especially after your team's impressive win at the Bolt.new hackathon. For our listeners who are still wrapping their heads around it, what exactly is vibe coding, and how does it fundamentally change how we approach software development?
Thanks, Maya. Vibe coding emerged from this realization that traditional programming education has kind of missed something crucial, that coding is deeply human. It's not just about syntax and logic. It's influenced by our mood, our environment, even the music we're listening to while we code. The breakthrough moment for me was recognizing that when we collaborate with AI tools, the most powerful approach isn't to think code first, but feeling first. Instead of starting with, what code do I need to write? We start with, how do I want this to feel? And then translate that vibe into technical choices. At the hackathon, we proved that teams who mastered this approach shipped features 3 to 4 times faster than those using conventional methods.
That's fascinating. I can see how this transforms the development process, but I'm wondering about the practical application. How does a team actually implement feeling-first thinking? What's the learning curve for developers who've spent years being taught that programming is purely logical? And honestly, doesn't this approach risk creating very subjective, inconsistent code bases across teams?
Great questions. Let me walk you through our workflow. The learning curve isn't as steep as you might think because we're actually unlocking capabilities developers already have. The key is structure. We start by capturing the feeling, collecting references, examples, or experiences that embody what we're trying to create. Then we translate those feelings into specific technical elements like color palettes, typography, or data structures. When we train teams, we use a framework called vibe mapping, where we literally draw connections between feelings and their technical implementations. As for consistency, that's where AI collaboration shines. When teams document their vibes clearly in shared PRDs, the AI helps maintain consistency in implementation across different developers. In fact, we've found codebases become more consistent because everyone's aligned on the intended feeling rather than just following coding standards mechanically.
That makes sense in theory, but I'm still trying to visualize how this works with actual AI tools. Could you walk me through a concrete example? Say I have this vision for an app that feels empowering yet calming, like a peaceful productivity oasis. How would the collaboration between a human developer and AI actually unfold to translate that rather abstract vibe into working code?
I love that example. So here's how it would play out. First, you'd create what we call a vibe doc, capturing that peaceful productivity oasis feeling. maybe with images of Zen gardens alongside productive workspaces, color references, and example apps that partially capture elements of what you want. Then, when working with an AI like Claude or in an environment like Bolt.new, your prompts would explicitly reference this emotional context. Instead of just saying, create a task management component, you'd say something like, create a task management component that feels like a peaceful oasis, where completing tasks should feel like dropping pebbles into still water, with subtle animations and a focus on white space. The key to good prompts is balancing these emotional descriptors with technical specificity. When the AI returns code, you evaluate it not just for functionality, but for how well it captures the intended feeling. It becomes this iterative dance where you're constantly checking, does this implementation match the vibe we're going for? When they don't align, you course correct with specific feedback. The animation feels too energetic for our peaceful oasis concept. Let's reduce the speed by 50%.
That's incredibly powerful. What strikes me is how this approach might actually bridge the gap between designers and developers, in a way traditional methodologies haven't quite managed. But let's talk about the business implications. How does vibe coding impact development timelines? And what's your response to CTOs who might view this as adding a layer of fuzzy thinking to what should be a rigorous engineering process?
You've hit on exactly why this approach is transformative for businesses. In traditional development, there's this massive translation loss that happens. Designers create mock-ups, product managers write requirements, and developers try to implement them, but something always gets lost in translation. With vibe coding, everyone rallies around the feeling we're trying to create, which actually speeds development. At the hackathon, we built in 48 hours what would typically take weeks. As for CTOs concerned about rigor, I get it. I was skeptical too. But what we've found is that engineering discipline doesn't disappear. It just gets applied differently. The vibes provide direction, but all the technical considerations around performance, security, and maintainability remain essential. Think of it like modern architecture. Frank Gehry still has to ensure his buildings don't fall down, even while creating emotional experiences through design. When you align AI with your creative vision, but maintain engineering discipline, you get the best of both worlds. Innovative products that delight users while still meeting technical standards. And honestly, the teams who adopt this approach simply ship better products faster, which is what every CTO ultimately wants.
So Kai, we've been talking about vibe coding as this intuitive, emotion-driven approach to programming. But I'm wondering, how do you actually translate those creative vibes into something structured that teams can follow? What's the bridge between that initial creative spark and actual implementation?
That's exactly the right question, Maya. The breakthrough moment for me was realizing we need a way to capture that vibe without losing its essence when we move to implementation. This is where a product requirements document, or PRD, becomes absolutely essential. It's like the blueprint that preserves your creative vision while giving it enough structure that you, or anyone on your team, can actually build it.
Interesting. I've seen plenty of PRDs in my consulting work, but they often feel so corporate and rigid. How does a PRD maintain that creative energy we were talking about with vibe coding? What's the learning curve for teams who want to preserve that spark?
I felt the same way about PRDs for years. The key shift is seeing the PRD not as bureaucratic documentation, but as a creative artifact itself. At the hackathon where we won using vibe coding, we created what I call a vibes-first PRD. We started with a mood board and emotional goals before diving into features. When you align AI with your creative vision through a well-crafted PRD, the AI becomes your creative partner rather than just a code generator. The document becomes this living bridge between your imagination and what the AI can help you build.
That's fascinating. Could you walk me through what elements you include in this vibes-first PRD approach? I can see how this transforms the traditional process, but I'm curious about the practical structure.
Absolutely. Let me walk you through our workflow. We start with a product overview that captures the essence. Like, for a coffee shop website, we'd write, a cozy website that evokes the feeling of a warm cafe on a rainy day. Then we create user personas that feel like real people with emotions, not just demographics. For example, Rainy Day Rachel, who seeks comfort and convenience. The feature requirements flow naturally from these emotional foundations. The breakthrough is that when we share this with AI tools, they understand both the functional needs and the emotional direction, which makes the code they help generate much more aligned with our original vision.
I love how you're humanizing what's traditionally been a very technical document, but what about scalability? How does this approach work when you have larger teams or more complex projects? Are there any specific sections you add to help AI collaboration specifically?
Great question. For larger projects, we add a vibe dictionary section that defines emotional and aesthetic terms the team agrees on. So cozy means the same thing to everyone, including the AI. We also include AI collaboration notes that specify which parts of the implementation would benefit from different AI tools. For instance, use Claude for conceptual UI descriptions, then GPT-4 for component structure, and Bolt.new for implementation. When we shipped our production apps, we found this orchestration approach reduced misalignment by about 70%. The business implications are massive. Faster development with fewer revisions because everyone, human and AI alike, is working from the same emotional and technical blueprint.
So Kai, we've been talking about product requirements documents and how they help structure development projects. But I'm curious, once you have your PRD in place, how do you actually communicate those requirements to AI tools? I've heard you mention prompt engineering during your Bolt new hackathon win. How does that bridge the gap between planning and execution?
That's such a great question, Maya. So prompt engineering is absolutely essential to vibe coding. Think of it this way. Your PRD captures your vision, right? But AI tools don't inherently understand that vision. The breakthrough moment for me was realizing that prompt engineering is like being a movie director. You have this talented AI crew with all the technical skills, but they need your guidance to create what you're envisioning. Without good prompts, you're basically handing someone a blank canvas and saying, paint something nice, versus giving them a detailed creative brief.
That's a helpful analogy. I'm thinking about the teams I consult with who are just starting to use AI tools. They often get frustrated when the AI doesn't produce what they want. What components should a well-engineered prompt include? And what's the learning curve like for teams adopting this approach?
You're hitting on exactly why teams struggle. At the hackathon, we proved that consistent structure makes all the difference. Let me walk you through our workflow. A well-crafted prompt typically needs 5 key elements: context about your project, your objective, the vibe or style you're going for, technical requirements, and sometimes references or examples. The learning curve isn't actually that steep if you use a template approach. We use something like, I'm building project type. I need specific component, that functionality. It should feel vibe aesthetic and use technical requirements. Teams usually see dramatic improvements within days of adopting this structure.
I can see how this transforms the AI collaboration process. Could you share an example of how different prompt qualities affect the output? I'm particularly interested in how this scales across different team members who might have varying abilities to articulate their vision.
Absolutely. Here's a real example from our team. We needed a button for a cyberpunk-themed music app. A junior developer might simply prompt, create a button for my website, and they'd get, well, a generic button, nothing special. But after our prompt engineering workshop, that same developer wrote, I'm building a cyberpunk-themed music app. Create a play button using HTML and CSS that glows electric blue, has a subtle pulse animation, shows a glitch effect on hover, and works on mobile devices. The difference was night and day. The key to good prompts is specificity without over-constraining. And what's amazing about teaching this skill is that it democratizes development. Even team members with less technical experience can contribute meaningfully when they learn to communicate their vision effectively.
That's fascinating. the business implications are significant. It's essentially unlocking creative potential across the entire organisation. I'm wondering about quality control though. When teams start scaling this approach, how do you ensure consistency and prompt quality? Do you have review processes or collaborative prompt development sessions?
That's such a smart question about scaling. When you align AI with your creative vision at an organizational level, you definitely need governance. In our production environments, we've implemented what we call prompt libraries, essentially a collection of proven prompts for common components and features. We also do pair prompting sessions where team members collaborate on crafting prompts for complex features. And we've found that prompt reviews can be just as valuable as code reviews. We actually track our most successful prompts and continuously refine them. One interesting pattern we've observed is that teams develop their own prompt culture over time, almost like a dialect that works particularly well with their specific products and technical stack. It becomes part of their competitive advantage.
So we've been talking about prompt engineering techniques, which has been fascinating. But I'm curious, how do you actually structure the entire collaboration process with AI? Like, do you have a systematic workflow that takes you from initial idea to finished product? I find many teams get stuck after writing a few good prompts, but don't know how to orchestrate the entire development cycle.
That's exactly the right question to ask, Maya. Prompt engineering is just one piece of the puzzle. The breakthrough moment for us was when we developed what I call an AI collaboration workflow as part of the vibe coding methodology. It's like, imagine you're choreographing a dance between human creativity and AI capabilities. At the Bolt.new hackathon where my team won, we actually mapped out 4 distinct phases that take you from abstract idea to production-ready code.
4 phases? That sounds really structured. I'm always looking for frameworks teams can adopt. What's the first phase? And how do you ensure teams don't just jump straight to implementation? That's what I see happening a lot. Developers get excited about AI and immediately start coding without proper planning.
Oh, I've seen that mistake so many times. The first phase is what we call vision formation. Before you type a single prompt to the AI, you need to clarify your own creative vision. We use simple vision documents, almost like mini PRDs, that capture the essence of what you're building. For example, when we built a cyberpunk portfolio site, we documented the feel we wanted: neon-lit, futuristic, edgy, and the key user journey. The critical insight is that AIs can't read your mind. They can only follow your lead. So being crystal clear about your vision first is essential.
That makes sense. It's almost like you need to know your destination before asking for directions. So once you have this vision document, what's next? I am particularly interested in how you bridge from these abstract concepts like edgy or futuristic to something concrete enough for an AI to work with.
That's phase 2, conceptual translation. This is where the magic happens. Let me walk you through our workflow at the hackathon. We took those abstract vibes like cyberpunk and edgy and translated them into technical specifications, specific color hex codes, typography choices, animation effects. It's like creating a Rosetta Stone that connects your creative language to the AI's technical language. So instead of just saying, make it cyberpunk, we'd specify, use neon pink bor FF00FF with scanline animations. This translation layer is why vibe coding works where other approaches fail. You're giving the AI precise technical direction while maintaining your creative vision.
That's fascinating. It sounds like you're basically creating a technical specification, but with the specific goal of communicating with AI. What's the learning curve for teams to adopt this translation phase? And I'm assuming the next phases involve the actual implementation, right?
You're spot on. The third phase is implementation dialogue. It's this beautiful back and forth conversation with AI where you're iteratively building components. And you've touched on something crucial about the learning curve. At first, teams struggle with conceptual translation because it requires both creative and technical thinking. But we found that after just 2 to 3 projects, developers get remarkably good at it. The final phase is integration and polishing, where you bring everything together. What's beautiful about this workflow is that it mirrors traditional development, but optimizes for AI collaboration. The business implications are significant. We've seen teams reduce development time by 60–70% while maintaining higher developer satisfaction because they're focused on creative direction rather than repetitive coding tasks.
So we've talked about setting up effective AI collaboration workflows, but I'm really curious about this concept you mentioned called vibe translation. What exactly does that mean in practical terms? I'm imagining some kind of bridge between abstract ideas and concrete implementations.
You've got it exactly right, Maya. Vibe translation is honestly where the magic happens in vibe coding. It's that process of taking something completely abstract, like, I want this app to feel like a cozy, rainy Sunday morning, and transforming it into actual technical specifications an AI or developer can implement. The breakthrough moment for me was during that Bolt.new hackathon when our team had this vision for an app that felt nostalgic but futuristic, and we had to figure out how to communicate that to AI in a way that produced consistent results.
That's fascinating, Vice Chair, because I've seen this problem come up with clients all the time. Someone has a clear feeling in mind but struggles to articulate it in technical terms. How does the structured approach work? And what's the learning curve for teams to adopt this kind of translation process?
I think of it like being a movie director, right? A director can't just tell their cinematographer, make this scene feel sad. They need to specify lighting, camera angles, music choices. Similarly with code, we break it down into a three-part process. First, you document your vision with core feelings and sensory attributes. Then you create what I call a sensory-to-code map, literally translating visual elements to color codes, movements to transition times. Let me walk you through a quick example. We had a client who wanted their finance app to feel trustworthy but modern. We documented that as clean typography, subtle blue color palette, precise animations, then mapped those to specific hex codes, font weights, and timing functions that AI could implement.
I can see how this transforms the entire product development process. Can you give me a more concrete example of what this documentation actually looks like? I'm trying to visualize how teams would implement this in their PRDs or design systems.
Absolutely. So for that finance app, our Vibe document started super simple, literally a markdown file with headings for core feeling and sensory attributes. Under sensory, we broke it down by visual, sound, texture, and movement. Then the magic happens in the mapping section. For example, under visual code translation, we had entries like trustworthy blue palette, primary, .03366, secondary, .017cc, and clean space, consistent padding, 24px, white space ratio, 60/40. For movement code translation, we specified precise interactions, transitions, 0.2's ease in out, and confident animations, transform with slight bounce, cubic Bezier, 0.175, 0.885, 0.32, 1.275. The key to good prompts is giving AI these specific technical details that map back to the feeling you want. The learning curve isn't steep because teams already have these conversations. We're just structuring them in a way AI can understand.
The business implications are really interesting here. This could dramatically reduce the back and forth between design and development, especially for companies with strong brand identities. How does this scale across teams, though? I imagine there might be resistance from more traditional developers who aren't used to thinking in terms of vibes.
That's where I've seen the most surprising results. At the hackathon, we had a team of 5 people with completely different backgrounds: a designer who never coded, 2 traditional developers, a product manager, and me. The traditional developers were actually the quickest to adopt this approach because it gave them something they've always wanted: clear, unambiguous specifications that still preserved the creative vision. When you align AI with your creative vision through this structured translation, development becomes both faster and more satisfying. One team I worked with reduced their design to implementation cycle by 68% using this method. the resistance typically melts away after the first successful project when developers see they're getting better results with less frustrating back and forth. It's about giving teams a shared language that bridges the creative technical divide while bringing AI into that conversation as a collaborator.
I'm still processing everything you shared about vibe translation. The idea of converting abstract feelings into technical specs is fascinating, but I'm wondering, once you've translated these vibes into multiple components, how do you manage all those pieces? What's the process for bringing everything together cohesively when you're using AI for different parts of a project?
That's such a great question, Maya. This is exactly where AI orchestration comes in. The breakthrough moment for me was realizing that building with AI isn't about getting one perfect prompt. It's about coordinating multiple AI processes together. Think of yourself as a film director. You're not personally operating every camera and light, right? You're orchestrating specialists to create a cohesive movie. Similarly, with AI orchestration, you're directing multiple AI assistants to build a complete application. At the hackathon where we won, this was absolutely critical to our success.
The film director analogy makes a lot of sense. But how does this actually work in practice? I can see how this transforms the development process, but what does the workflow look like? And what's the learning curve for teams trying to implement this kind of orchestration?
So in practice, we use several key patterns. The most fundamental is what I call divide and conquer. Let me walk you through our workflow. Say you're building a portfolio website. Instead of one massive prompt, you break it down into components: a hero section, about me, project showcase, contact form. You work with AI on each piece separately, then integrate them. The learning curve isn't as steep as you might think. Teams usually grasp it quickly because it builds on familiar decomposition principles. The difference is, you're breaking things down based on what makes sense for AI collaboration, not just code organization. When you align AI with your creative vision this way, the results are honestly transformative.
That makes sense for the initial development, but what about the refinement process? The business implications are huge if we can actually get high-quality results without endless back and forth. How do you avoid getting stuck in prompt tweaking limbo?
That's where our second pattern comes in: iterative refinement. The key to good prompts isn't perfection on the first try. It's having a structured approach to improvement. We start with a basic implementation, then progressively refine it with specific feedback. For example, make the background gradient darker, or add animation to this element. This is way more efficient than trying to get everything perfect in one massive prompt. And there's a third pattern called parallel exploration, where you generate multiple approaches simultaneously, compare them, and choose the best elements from each. At our company, we've found these patterns cut development time by nearly 60% while actually improving quality because you're working with AI's strengths rather than fighting against its limitations.
I'm seeing how this could completely transform how teams approach development. But when you're orchestrating all these AI processes, how do you maintain consistency across the project? And how does this scale across teams with different skill levels or familiarity with AI?
Consistency is absolutely critical, Maya. We use what I call shared context, essentially a project-wide prompt that defines the visual language, coding standards, and overall vibe. Every individual AI interaction inherits from this shared context. As for scaling across teams, that's actually where this methodology really shines. We've implemented this with teams ranging from AI experts to folks who were practically technophobic before. The breakthrough was creating standardized orchestration templates, almost like sheet music that guides how different team members conduct their part of the AI orchestra. Junior members might follow prescribed patterns, while seniors might improvise more. But everyone's working from the same playbook. When we rolled this out at enterprise scale, we saw adoption rates of over 90% within just 2 months, because it actually makes development more accessible and, honestly, more fun.
So, Kai, we've been talking about AI orchestration patterns, and I'm really curious about how these patterns actually live in different environments. From development to production, how does your vibe coding methodology adapt as code moves through these different phases?
That's such a great question, Maya. The breakthrough moment for me was realizing that code is actually like a living thing that needs different environments as it grows. When we won that Bolt.new hackathon, we had to be super intentional about our development setup. We started calling them the 3 gardens of code. You've got your nursery where the code first sprouts, the greenhouse where it hardens, and finally, the open garden where users experience it.
The 3 gardens of code. I love that analogy. But I'm wondering about the practical side. What's the learning curve for teams transitioning between these environments, especially when they're collaborating with AI tools? Do you find teams struggling with configuration differences, or is it more about the mindset shift?
Well, it's definitely both. Let me walk you through our workflow. In the development nursery environment, we're much more experimental with our AI prompts. We might try 5 different approaches to generating a feature. We use fake data, turn on all the debugging, and it's very much a safe space to fail. The key to good prompts here is iteration speed, but once we move to staging, our greenhouse, the focus shifts to making sure our AI-generated code integrates properly with everything else. At the hackathon, we proved that having separate prompt templates for different environments is crucial.
That's fascinating. I can see how this transforms the traditional development pipeline. What about production? I imagine there are some unique considerations when your AI-assisted code finally goes live. How do you handle things like monitoring or debugging AI-generated code in production?
Production. That's where the real magic happens. When you align AI with your creative vision, but then actually ship it to users, there's nothing like it. In production, we've learned to build in more guardrails around our AI systems. For instance, we create what we call vibe validators, essentially test suites specifically designed to catch the kinds of edge cases AI might miss. The breakthrough moment was when we started implementing observability specifically for our AI components, tracking things like prompt success rates and generation quality in real time. It's a whole different ballgame when real users are interacting with what your AI helped create.
The business implications are significant here. I'm particularly interested in how this affects deployment frequency. With traditional development, moving through environments can be slow and cautious. Has vibe coding with AI changed how quickly you can safely move from development to production? And what about the cost considerations across these environments?
You've hit on something huge, Maya. Before embracing AI collaboration, our team would spend weeks in each environment. Now, we can sometimes go from concept to production in days. The key is that we're not just using AI to generate code faster. We're using it to generate tests, documentation, and deployment scripts too. As for costs, here's something interesting. Our development environments actually cost more now because we're running more AI iterations. But our production deployment costs have dropped about 30% because the code is more efficient. When teaching teams vibe coding, I always tell them, invest in your nursery and your garden will thrive.
So Kai, we've talked a lot about development environments for AI collaborative coding, but I'm really curious about what happens after deployment. How does the vibe coding methodology handle the operational side of things? What's the learning curve for teams transitioning from traditional ops to managing AI-assisted applications in production?
That's such a great question, Maya. The breakthrough moment for us was actually realizing that operational procedures are even more important when you're working with AI-generated code. At the hackathon, we proved that having solid runbooks and incident response plans specifically designed for AI collaboration was the difference between winning and losing. Let me walk you through our workflow. We create what we call AI-aware operational procedures that account for the unique aspects of code that's co-created with AI.
That's fascinating. Could you give a concrete example? I'm trying to visualize how a runbook might look different when it's designed for an AI collaborative project versus a traditional one. How does this scale across teams, especially those new to the vibe coding approach?
Absolutely. So here's a real example from our production environment. Our runbooks include sections specifically for prompt forensics. When something breaks, we need to understand if it was due to the initial prompt, the AI's interpretation, or the implementation. For instance, one runbook step might be review the prompt-to-code mapping documentation to identify misalignments between intent and implementation. We've found that when you align AI with your creative vision, but something still goes wrong, the issue is often in that translation layer. The key to good runbooks in vibe coding is documenting the prompt chains that led to critical components, so anyone on the team can understand both the code and the thinking behind it.
Oh, that makes so much sense. It's like adding a whole new dimension to debugging. Not just, why is the code failing, but why did the AI interpret my requirements this way? I can see how this transforms incident response too. What about recovery procedures? The business implications of downtime are significant, so I imagine you've developed some unique approaches there as well.
You're exactly right, Maya. For recovery procedures, we've actually invented what we call prompt rollbacks. When an AI-generated component fails, sometimes the fastest way to recover isn't traditional code fixes, but actually re-prompting with better constraints. During the Bolt.new hackathon, we had a critical UI component fail just hours before submission. Instead of manually fixing the code, we identified the flawed prompt, refined it with more precise boundaries, and regenerated the component with Claude. We were back up in minutes. The breakthrough realization was that in vibe coding, your prompts are as valuable as your codebase, maybe even more so. So our recovery procedures include prompt versioning, a library of successful prompts, and templates for common fixes.
Wait, so you're essentially treating prompts as infrastructure, almost like infrastructure as code, but it's infrastructure as prompts? That's incredibly powerful. What's the learning curve for teams to adopt this kind of operational thinking? And how do you handle the documentation aspects? I imagine traditional docs might not capture the nuances of these AI collaborative workflows.
You just nailed it with infrastructure as prompts. I might have to steal that phrase, Maya. The learning curve is actually less steep than you might think, especially for teams already comfortable with DevOps practices. The key is to start small, document one AI workflow really well, create runbooks for your most critical AI-generated components first. As for documentation, we've developed a dual-layer approach where the AI actually helps document itself. When we generate code with Claude or other tools, we immediately prompt for operational documentation, including potential failure modes and recovery steps. This self-documenting aspect of vibe coding has been game-changing for our teams. When you leverage the same AI that wrote the code to help write the operational procedures, you get incredibly precise and helpful documentation that captures all those nuances you mentioned.
So let's shift gears a bit. We've talked about keeping apps running smoothly with operational procedures, but I'm really curious about quality control. What happens after you've used AI to generate code? How do you make sure it's not just functional, but actually good? I imagine there's a learning curve for teams transitioning to this approach.
That's such a critical question, Maya. The breakthrough moment for us was realizing that AI-generated code needs a different quality assurance framework than traditionally written code. At the hackathon, where we won with Bolt.new, we developed what we call the 4 dimensions of code quality. See, when the AI gives you code that technically runs but feels off somehow, you need a systematic way to evaluate what's missing.
4 dimensions? That sounds intriguing. In my consulting work, I've seen teams struggle with exactly this issue. They get something that works, but aren't sure how to objectively assess its quality. What are these dimensions, and how do they help teams standardize their evaluation process?
Let me walk you through our workflow. First is functional quality. Simply, does it work? This includes manual testing, edge cases, checking for console errors. Second is structural quality. Is the code well organized? We look at readability, organization, naming conventions. Third is experiential quality. Does it create the right feeling? This is where your vibes come in. Does the UI match the emotional target? And finally, adaptive quality. Can it evolve effectively? Will other developers understand it 6 months from now?
I can see how this transforms quality assessment into something more holistic. The experiential dimension particularly stands out. It's often overlooked in traditional QA. How does this scale across teams, though? Are there specific tools or processes you've implemented to make this systematic rather than subjective?
Absolutely. The key to good prompts is actually building these dimensions into your requirements. For example, when working on that weather dashboard with the calm, minimalist aesthetic, we created a QA checklist for each dimension. For experiential quality, we'd ask team members to rate how calm the interface felt on a scale of 1 to 10. We'd validate structural quality by having AI explain the code architecture back to us in plain English. When you align AI with your creative vision and your quality standards, that's when the magic happens.
That's fascinating. The business implications are significant, potentially reducing QA cycles while improving consistency. But I'm wondering about the learning curve. Do you find that developers with traditional backgrounds struggle with evaluating that experiential dimension or with articulating quality requirements to AI in the first place?
That's where the vibe coding methodology really shines, Maya. Traditional developers often excel at functional and structural quality, but might initially struggle with expressing experiential requirements. We've developed a prompt template library specifically for QA that helps bridge this gap. One technique we use is the vibe translation exercise, where developers practice translating feelings into technical requirements, like what does calm mean in terms of animation timing, color palette, and information density? At the hackathon, we proved that with just 2 to 3 hours of training, developers can get comfortable with this new paradigm. The most exciting part? Teams report it makes development more enjoyable because they're connecting with the emotional core of what they're building.
So after all that discussion about quality assurance, I'm curious about how you handle documentation in your vibe coding workflow. In my consulting work, I see so many teams struggle with maintaining good system docs. They build amazing things with AI assistance, but then 6 months later, no one remembers how it all fits together. How are you approaching this with your teams?
Documentation has become absolutely critical in our AI collaborative workflows. You know, it's funny. When we first started using AI to accelerate development, we actually thought we might need less documentation since the code was being generated so quickly. But we had this breakthrough moment during the Bolt.new hackathon when we realized the opposite is true. When you're co-creating with AI, documenting your system architecture becomes even more important because the relationships between components evolve so rapidly.
That's fascinating. So what does system documentation actually look like in a vibe coding context? Are you documenting different things than in traditional development? Or is it more about adapting traditional documentation approaches to this new paradigm?
We've evolved traditional approaches to fit our AI collaborative workflow. We still use the 4 pillars: architecture docs, change logs, vendor contacts, and operational procedures, but with some key differences. For architecture docs, we create what we call vibe maps, simple mermaid diagrams showing not just component relationships, but also which parts were human-directed versus AI-generated. This creates accountability and helps new team members understand the system's DNA. Let me walk you through our workflow. When we start a new feature, we actually prompt the AI to generate the documentation skeleton first. Then we iterate on the implementation and docs simultaneously.
I love that approach. The vibe maps concept makes so much sense for tracking the hybrid nature of AI collaborative code. What about change logs? I imagine the pace of development is much faster when using AI tools, so how do you keep those meaningful without them becoming overwhelming?
That's where we had to get creative. With traditional development, you might make a few significant changes per sprint. With vibe coding, you might iterate 15-20 times in a single day. The breakthrough moment was when we started categorizing changes by vibe shifts rather than individual updates. A vibe shift represents a meaningful directional change in the project, like switching from material design to a custom design system, or refactoring for performance. Each vibe shift gets documented with the high-level intent, the key prompt that initiated it, and the resulting architectural changes. This gives you a semantic history rather than just a chronological one.
That's a complete mindset shift from traditional changelogs. I can see how this transforms documentation from a chore into an integrated part of the development process. What about operational procedures and vendor contacts? Those seem especially important when you're orchestrating multiple AI tools like Claude and Bolt.new alongside traditional services.
Absolutely critical. When you're using multiple AI tools, each with different capabilities and prompt patterns, documenting those relationships becomes essential. We maintain what we call a prompt registry that documents exactly which AI tools we're using for which purposes, along with the effective prompt templates and examples. For operational procedures, we actually co-author them with AI. We'll describe a process in high-level terms, then have Claude or GPT expand it into detailed steps, review it, and refine it. The key to good documentation in vibe coding isn't just recording what you built, but capturing how human creativity and AI capabilities combine to create it. When you align AI with your documentation needs, the docs become almost like another team member, something that evolves alongside your project rather than an afterthought.